Hello, algebra students. Here is your Chapter 6 review. Remember, the test is going to be Thursday. I don't think we can give it Wednesday because of the assembly, so we'll do it Thursday. All right. Um, First of all, there's about 14 problems on here. I'll do them as quickly as possible. We'll do a quick inequality here. We'll solve it, and then we'll graph. And remember that when we solve equations and inequalities, we've got to listen to Saddam. And also remember that if we ever multiply or divide by a negative, our inequality is going to change direction. Or if we had this, it would turn into that. So, okay. All right. So, on this one, I'm going to undo the subtraction first by adding 8. And I will get 2m greater than 10. I'll divide by 2. And I'll get m must be greater than 5. Now remember, don't use any little trick to tell you which way to shade. Plug in a number that makes that true. For example, 6 is greater than 5. So on my number line, 5 would be here, 6 would be here. I'm going to have an open point on 5. I'm going to shade towards 6. All right. So here's a compound inequality. And remember, when I have ors, they tend to graph something like this. Okay, when I have ands, they're going to look like that. Of course, the points might be closed. All right, so first of all, I'm going to listen to Saddam, and I'm going to get rid of the addition first. This is a plus 1. So I'm going to get rid of the addition first. I'm going to subtract 1 from both sides. And when I do that, I'm going to end up with negative 2x less than or equal to 12. And then I will divide by negative 2. Divide by negative 2. X is going to be greater than or equal to negative 6. There's where the flipping the inequality came in. Or, and of course over here I'll have to add 5 to both sides. And I'll have x is less than negative 10. And so this is my solution here. Now when I graph that on a number line, I'm going to show negative 10 right here and negative 6 here. And then I'm going to have a closed point on negative 6. I'll have an open point on 10, negative 10, and then I'll test, I'll see what makes it true. What number is less than negative 10? Well, negative 12. That would be this way. Okay, this one here. What is greater than negative 6? How about 5? And we will go this way. And there you go. Pretty simple stuff. All right, remember, you should know the definition of absolute value. That is the distance from 0 on a number line. Okay, so absolute value negative 5 is 5 because it's 5 spaces from 0. But when I have a problem like this, there's going to be 2 answers because x could equal 10 because 10 is 10 spaces from 0, or x could equal negative 10 because isn't that 10 spaces from 0 as well? All right, now 6 and 7, you got to stick on a brain cell, right, Andrew? We have the distance being less than a negative number. That is not possible. There's no solution. The distance cannot be a negative number. It's got to be 0 or a positive. Number 7, the distance is greater than a negative number. Well, if the distance has to be 0 or a positive, doesn't it have to be greater than a negative? That'll be all real numbers. Okay, so now let's look at one like this. And this is where this is a great or, remember, great or problem. So I'll use my little roots 2x plus 5 greater than or equal to 25, or 2x plus 5 less than or equal to negative 25. I subtract 5, I get 2x greater than or equal to 20, divide by 2, x is greater than or equal to 10. Or, I'll subtract 5, 2x less than or equal to negative 30, divide by 2, divide by 2, x is less than or equal to negative 15. So there's my solution. And when my number line, I need to show negative 15. I need 10. Closed points. Okay. I need numbers less than negative 15. Those would be this way. And numbers greater than or equal to 10 are this way. And there we go. And that's usually how ORs will graph. All right. Number 9 is a less than, right? And I'll break it down into two pieces. 4 minus 3x is less than 16. And 4 minus 3x is greater than negative 16. So I'll subtract 4. I'll get negative 3x is less than 12. I'll divide by negative 3, divide by negative 3, and then x is going to be greater than negative 4. If you're wondering why, remember I divided by negative 3, so my inequality had to flip. Okay, I'll subtract 4 here, subtract 4 there. We get negative 3x is greater than negative 20. Divide by negative 3, divide by negative 3. X is going to be less than, and that's going to be 6 2/3, I believe. So here is the algebraic solution right there. And then on the number line, I'm going to put negative 4 on, put 6 2/3 on, and it's going to be an open point and an open point. Now I need the numbers greater than negative 4 and less than 6 2/3. Well, that would be all these numbers here. Okay? Remember, make sure you're asking yourself what these solutions mean. Don't just get them and go, cool, I'm done. All right, I'm trying to go through these kind of quick. You can always pause them, slow down, repeat. All right, let's take a look at this one here. Problem number 10. Got a graph an absolute value function. Now remember, when I do graph it, I'm going to get a V shape, right? Something like that. Of course, the V could open downward. In this class, you'll never have a V open sideways. Algebra 2 or something, that certainly could happen. All right, the first thing I'm going to do is I'm going to find my vertex, right? Well, the vertex for this one, the x-coordinate will be negative 1, and the y-coordinate will be 3. So I'm going to go negative 1, 1, 2, 3. Okay. Now I look here for my slope, and I'm going to rise 1, run 1, 2, 3. Rise 1, 1, 2, 3. Rise 1 back, 1, 2, 3. 1, 2, 3. Very wide V. And so, let me see here. I think that's what I want. Like this. And there you go. Pretty simple stuff. All right, coming over to this next one, we'll find my vertex. That'll be +3 and +4. Remember, the y-coordinate doesn't change signs. The x-coordinate does. So I'm going to go 1, 2, 3, 1, 2, 3, 4. It's a negative here, and so I know it's going to open downward, and it's like a -1 because there's no number there, so I assume it to be 1. So I'll go down 1, right 1, down 1, right 1. Of course, I go down 1, left 1, down 1, left 1, and there's my V. And I'm ready to graph. And there we go. Okay, so here comes number 12. This one, it kind of looks like y equals mx plus b. My y-intercept is going to occur at 0, -1. And that's right there. And then my slope is 2 over 1, right? 2 over 1. So I rise 2, run 1, rise 2, run 1. Okay, now it's not equal to, so there's going to be a broken line. So we get a nice broken line like that. And now I've got to see which side of that line I'm going to shade. So I can use 0, 0 as my test point. So put 0 is greater than 0 minus 1. Is 0 greater than -1? You bet your boots it is. So I'll shade this side of the line. Okay, now if we come over here, I'm in standard form. So I might like to use a t-table. I'll plug 0 in for x to find the y-intercept, in which case y is going to be -2. So 0, -2 is right there, right? Plug 0 in for y, that turns into 0. So I'll have 2x is equal to 8, and that'll be 4. 1, 2, 3, 4. Okay, I notice my slope is up 2, right 4, up 2, 1, 2, 3, 4. Okay, now it's equal to, so it's going to be a solid line. Okay, so um, now there's still going to be shading, right? So I can use my test point of 0, 0. I like to use 0, 0. Only time I can't is when the line goes through 0, 0. 0 minus 0 greater than or equal to 8. Is 0 greater than 8? It is not. And so in this case, I will shade below the line. And there it is. That's all there is to it. I know I said there were 14 problems. I can't remember. I think that's actually 13. I think I misspoke, or I possibly misnumbered. But anyway, there's your review. It's only 15 minutes, but take your time, go through it. Watch it more than once. Make sure you know how to do everything. Some of you really need some good scores on here. All right, Mr. Lawrence signing off. Good night, everybody.